So let us start the lecture with regard to latest news on Industry 4.0. And as you can see that Industry 4.0 is regarded as one of the most prominent technologies of the future. And it has already started the revolution starting from Germany, USA, China, Korea, and even India. So the latest news you can see that even the lots of automobile sector and manufacturing sector are actually adopting Industry 4.0 for smart production and sharp automations. So you can say that we have today got a new term called Quality 4.0 that is actually being controlled with the help of smart robotics. We have the data integration that is regarded as a key driver for Industry 4.0. And last but not the least, additive manufacturing and predictive maintenance, they are taking a next step towards, you can say, quantum leap for adopting artificial intelligence for manufacturing. So the future, everybody, it will not be focused on cloud computing, IoT or blockchain. Artificial intelligence and the critical application of Industry 4.0 will also play a multifaceted role so that the industries can become more better into production for increasing the efficiency, reduction of cost, and improving the profit. So the industrial revolution, you can see that we started from 17th century when we started with mechanical production, then followed by electricity and division of labor in 18th century. Then we have automation, and followed by today we all know regarding with regard to robotics that we know as automation, autonomous machines, and virtual environments. And today we all know we are under COVID-19 pressure, and most of the factories are closed down and we are working from home. So Industry 4.0 could be a blessing for us to understand that how we can automate the industries so that rather we can have the workers on the factory foreground, we can control the factories from the home. So you can say that the starting of innovation of industry, it started from 1712 with the invention of steam engine by James Watt, followed by 1840 with telegraphy and 1920s in Taylorism. And the revolution actually started in front of mankind when we have computers, microcomputers by Apple I. And now we all know about Internet of Things, 5G, autonomous vehicles, future transportations, and many other things. But you will be surprised to know, everybody, that as we talk of smart cities, smart grids, and very few people talk about Industry 4.0, Industry 4.0 is an equal leader, because the future will not be only focused on smart grids and smart cities and IoT or healthcare. Industry 4.0 is one of the critical applications, and this time we must learn that this COVID situation has opened the widened doors for industry, that it should adapt Industry 4.0 in a very early stage, starting from next year. Because in the next coming slides of my lecture, you will all agree with me that without Industry 4.0, the industries will not play a key role for better production and better human and computer interaction. So the Industrial Revolution, you can say that the foundation stone was taken by England. Most of the revolution, it started from England. Then we know about French Revolution, Russian Revolution. And today we all say it's known as IoT revolution or technological revolution. So still we need to improve our hearts, we need to improve ourselves, and we have to modify the technologies so that the technologies can be used more effectively towards the betterment of the mankind. So the first Industry 1.0, you can say that it was actually started with the live practice of first mechanical loom in 1784. So Industry 1.0 started from actually 1784, followed by second industrial revolution in 1870. Then we have the third industrial revolution that was actually known as embedded systems, that we had the PLC, programmable logic controller. Then today's industry that is starting from 2020, you can say that it is with the power of Internet of Things, AI, blockchain. You can say about smart sensors, intelligent computing, drones, we all say. But the main thing is that today we are actually leading towards betterment, flexibility, and scalability, but degree of complexity, it is increasing. So we need to program, we need to plan something better in order to make the industry better and future ready for Industry X.0. So as I've already told you, the phases of industrial revolution, the Industry 1.0 with 1760 to 1840, railways and steam engines, 1870 to 1940 with electricity and assembly line, 1960 to 2010 with computers, personal computers, and from 2010, or you can say 2015 onwards, we have automation, IoT, 5G, and even in the near future, we can expect something with regard to the quantum computing that will be all part of this type of industrial revolution, or you can say the quantum revolution for industry. So this data actually needs to be understood. You can say that the global competitive index for version 4.0, 2019, 2020 index will be launching soon. So the number one country that is leading towards innovations, early adoption of technology, as well as improving their technological revolution is Singapore with a score of 84.8, followed by USA, 83.7. But we all know it's a COVID situation and very less innovations happened this year. So maybe the country's leg will come down. But now healthcare industry is becoming the central point of attraction for research and even to find more hearts in order to find more revolution and improvement, how we can improve the healthcare, we can improve the clinical trials, and how we can have quick manufacturing of the antidotes in advanced pharmaceutical companies. So talking of India, the rank right now is 28 and the score is 73.9. So I will not say that the score of India is very bad, but I will not even say that it is even good. We all know we have Digital India, Startup India, but these movements are there, but we are waiting for that eye candy revolution that can make us stand in front of Europe, China, Korea, and lots of other automated countries. So this score we need to improve. And you can say that the Sri Lanka is 84, Nepal is 108, and China leading at 28. So still we need to think of the rank of 68, and we need to think that how we can revolutionize India, that it can become a global superpower in healthcare at least, or maybe with some automation of Industry 4.0. Because in India, we have lots of industries and the scope for Industry 4.0 is wide and open for adaptation and early detection. So this is the global competitive index for version 2.0 for India. You can see over here that the rank of India is not so good. You can say in terms of institutions, we have 59th number rank, but in health, you can say it is 110th, which is not good. And 103rd in labor market, and third is in the market size. So if you talk of some of the, you can say the analysis of this graph, we can say that still India needs to put up. The only answer is that we need to early adopt the technology like Singapore, Hong Kong, USA, France, China, and Japan. So the speed of technological change, you can say that these are some of the exponential technologies that you can see, and that is actually making up and actually being adopted by industry for speeding up their industrial revolution or manufacturing. That is called biotechnology today, neurotechnology, nanotechnology, new energy and sustainability. Sustainability is a very important word. Sensors, 3D printing, AI, robotics, blockchain, and IoT. So if you talk of this type of quantum leap, we are actually moving from linear expansion to quantum expansion. And that is what we have to see, that how even the transportation can be changed from simple engines to fully automated cars, from traditional cities to smart cities to sustainable cities, from simple traditional hospitals to modern clinical healthcare systems. That's what we have to revolutionize with the adoption of these technologies in the real time. So in terms of manufacturing perspective, you can say that we started with phase one when we have new paradigm and manufacturing vision. So you can take any case study. Imagine you can go to any factory where garment goods are there, where they are producing some FMCG goods or other things. You want to revolutionize that. So give yourself as a case study that how you can automate that industry and how you can make it as a strong competitor, or you can say a best competitor internationally. So I'm not talking of a national market. I'm talking of an international competition where the scope for adoption and the scope for competition is very broad. But you can say when we go for phase two, we have factories of the future, which we actually know as the smart factories. And in the phase three, we have the vision of manufacturing, that is Vision 2030, in which we actually go for remote services. So imagine yourself, everybody, that it's a lockdown, workers are going back to their hometowns and all the factories are shut down. But with the power of Industry 4.0, I will be showing you the technologies. So we can even run the factories even without a single labor, and we can do it remotely. That is what the vision is. And that we have to work, and that's what we have to do in live case studies, that how we can bring up the fusion of technologies to make up the vision of manufacturing 2030. So the global GDP, very important for us to understand, it is $70 trillion, out of which you can say developing economies share about 29 trillions, and advanced economies share about 41 trillions. So the only revolution that needs to be focused is becoming an industrial economy. So don't think that we make the India with some luxury brands. Don't think. We must think that how we can make India an industrial brand. how we can make the products in such a manner that are actually being dependent by the other economies, and we can become not only competitors, but we can become the early adapters that other countries are using our products and adopting our technology. That is what we have to do. And that what would be the mission for Digital India or Startup India in the next coming 2 years. So the challenges, why Industry 4.0 is actually required, that is the main challenge today. So the biggest challenge, as you can see, it's a lockdown period and factories are closed down and the production has come to the halt. And that's the biggest challenge. So I pray to God, everybody, that in front of all of you in publicly, I would like to say that God should not give us this type of COVID-19 terror in the next coming 100 years. But if this terror comes, if this thing happens in the near future, are we ready for that? We must be ready. So for that, in that terror, the only thing that can keep the industry to the up to the scale mark to keep the production going on is Industry 4.0. So the question is, what are the challenges? The challenge is that the production should be 24/7 and efficient manner. We should shorten the product life cycle, reduction of lot size, price decline, cost optimization as per operations research and logistics, shortening of return of life investment and saving of resources. But the only thing is that is possible with Industry 4.0 is globalization, sustainability, economic cycles, and above all, individualization. I will be showing you some of the slides in the end that even now you can make the complete aircraft without having a single worker on the assembly line. You can even run an airport without having a single worker working on any end part of the airport also, even with the security checks also. So this Industry 4.0 is not going to revolutionize yourself, but it is going to innovate and change everything that we see the world of today, and we can think of the world of tomorrow. So this is the person, everybody, and many people ask me this question, sir, who actually coined Industry 4.0? So the person is German. He is Heinrich von Schiele. He is known as the father of Industry 4.0. Actually, Industry 4.0 actually started from Germany now. So after that, it came to China, USA, France, Korea. Everybody is working. So what is Industry 4.0? The primary goal is 3. The first thing is to have smart production. And the smart production can only come with high precision only when the machines are taking over the low bottom line assembly line and we are doing the complex repetitive tasks with no errors. Why robotics are required? So many people give this question that why robotics are required. So the only baseline answer I would like to give you that human beings are very bad in terms of doing the repetitive task. If we do the repetitive task, we start making the mistakes, and repetitive task, our efficiency comes down. But robots are actually designed and AI is actually required in order to automate the repetitive task in a precision manner. So that is what we have to bring in terms of smart production. So the production should not be stopped. Second is green production. Then we have urban production. So these 3 things as a fusion are known as the pillars behind the mission critical applications of Industry 4.0. So there is another $1 million question in front of you. Is Industry 4.0 evolution or revolution? So what is evolution? Evolution means that first of all, we try to improve something. You can see, consider this phone. You can say a vintage analog phones, the technology will remain the same. Same we have the lease line, same we have the BSNL, just we change the shape of the phone. It's just innovation. But if we replace these landlines to the smartphones of today, like iPhone, it becomes a revolution. So consider that even if you have these smartphones, but in the future you have these holographic phones or you have the foldable screen phones, that also becomes a revolution. So Industry 4.0 is a mix of both innovation and revolution, which means that it is gradually improving the process, but it is improving the process and it is throwing back the traditional process into an automation process. That's why the fusion of innovation and invention, evolution and revolution all works with Industry 4.0. US manufacturers are taking a crucial role in terms of Industry 4.0. And you can see that 35% data is collected by sensors, 70% industries are already started adopting IoT, cloud computing, and AI. You will be surprised to note, everybody, that about 5 years back, when I used to give some freelance implementations, I used to take 2 to 3 days to give up the server, to make the mail server, everything. But now if you are a single person with just a laptop and you just take a subscription from cloud, from Amazon, you can run your own company with your own servers in less than $65. And that's what the power of adoption. that how we can reduce the cost of start and how we can start implementing in the real time. That is what we have to see. And that's how the startups are coming and improving, and how the companies are actually running from just a laptop with just a piece of desk. The internet, industrial internet of things market, it is going to be the revolutionary market in the world after healthcare industry now. It can expect it to touch about $600 billion by 2021 itself. It's the latest data. And this data is quite fascinating me, that if it is reaching $600 billion, which means that from next year onwards, no industry can breathe without IoT and cloud computing. And that's all what is the data is saying. That's what I'm not saying this, what the data is saying to me. The industry 4.0 environment will be surrounded by four things. Internet of things, internet of data, because today you can say that the data centers capacity requires a quantum lift. Imagine when Facebook started today, how is Facebook? Imagine when Instagram started today, how much requirement is from the Instagram. Imagine when YouTube started today, how much videos are uploaded in 1 minute. Internet of services, everything, whatever you want to have in the future will be provided by the internet. And internet of people, the social media, we all know. And if you combine together these things, the four things, you are actually making the environment for industry to operate. That is actually known as Industry 4.0. So the question now stands. Now I would like to explain you, all of you, that what exactly is Industry 4.0. So you can say that it provides with six different technologies. One is automation with robotics, or you can say cobotics, connectivity with 5G, cloud computing, Internet of Things with sensors, smart sensors, big data, and above all, integration of systems. So if you combine these six technologies together, you can say it is becoming Industry 4.0. So Industry 4.0 is basically an innovation, evolution. But because these things are improving day by day, you can say that from 2021, the word IoT will not be IoT, it will be Internet of Everything. So how these things are getting evolved, it is actually concerning and improving Industry 4.0. You can say that we have a complete ecosystem with suppliers. We have the cloud computing. We have digital production where we have no workers on the assembly line. But don't think that computers will replace us. I will be giving you this answer later. So we can have the customized products. Why not, everybody, that there was a time when we have branded computers? Why not we will also make our own smartphone with our own display, our own RAM, our own storage? That can be possible, and that will be possible in the near future. So the leading Industry 4.0 vendors, you can see this is one of the popular websites. I use this website for the data only, even for my research papers, whenever I write. So IoT Analytics is a website, and you can see that we have lots of companies connected all over the world. So almost every company that you think on the planet today is actually known as the service provider or even having the client for Industry 4.0, because they are actually surrounded by these six technologies. So you can say with accelerating pace of change, and this data again fascinates me, I'm saying. You can see over here, from agriculture revolution to industrial revolution, it has taken 8,000 years. 8,000 years, everybody. Industrial revolution to light bulb, it has taken 120 years. From light bulb to moon landing, it has taken 90 years. Moon landing to World Wide Web, which means World Wide Web has become across the globe, it has taken 22 years. But from World Wide Web to quantum computing and even the DNA computing, it has only taken 9 years. And you can see over here that by 2020 itself, the computers are already bypassing the brain power of the rats. And if you combine together these rats, which means that we are actually understanding the brain power, and we are expected, as a scientist, I'm saying you, because I'm a computer scientist, as a scientist, I'm saying you that the computers are expected to surpass the memory power of theirs, the microprocessors, with 2023 as compared to the human brain power. So maybe computers can harness the full potential which the human beings cannot harness. And this data is actually giving the shape of this thing. So world growth towards initiative towards Industry 4.0. And you can see right now that Germany has made the revolution that is known as Industry 4.0, followed by Made Difference. USA has manufacturing resonance. We have Make in India. China has Made in China, and Japan has Innovation 25. So ask yourself, everybody, ask yourself one question. We are into COVID situation. Do we have any plan for industry, that how the industry can bridge up the production, match up the profits with Make in India progress? That's what we have to see. So getting a movement is different thing. Using that movement, innovating the things and taking it to the real time, it's a different thing. So imagine that the work requires to be done. So Industry Revolution 4.0 is basically a combination of several innovation technologies in terms of robotics, blockchain, IoT, automation, digital fabrication, 3D, cloud computing, and even autonomous technology. And if you combine together to improve the value chain and keep the business up and running using the power of cyber physical systems, you are actually making that business Industry 4.0. So you can take any case study like a cold storage, how you can automate that cold storage, how you can monitor the cold storage remotely. So you have the sensors, you have the IoT, you have the cloud, you have cybersecurity, you have cyber physical systems, just go and implement it. So Industry 4.0 is actually leading with three major pillars. That is one is physical, digital, and generate movement. So that's how we actually go for analysis, digital sensors, and analytics. So even you can say that data science is one of the best parts of Industry 4.0 because IoT is there. So four characteristics you can see, we have vertical networking, horizontal integration, thorough engineering, and exploration. So which means from every angle from 1, 2, 3, 4 points, we have actually known as the innovation at the first point. And adoption at number 2 with the mission critical applications towards extensibility, flexibility, and above all, sustainability. That's the answer, everybody. And that's all we can say, that Industry 4.0 is not a technology, it's an ecosystem for the mankind to live the new future world. Industry 4.0 implementation, you can say that we have the 4 layer, like you study the TCP/IP structure or OSI model. We also study this type of structure with 4 layers. The first layer is known as a physical layer that is actually comprising of sensors and actuators, the connectivity, the hardware. Then we have systems, then like IoT, then we have connectivity, how you connect them, because in the future, only Wi-Fi and Bluetooth will not be there. We require of LoRaWAN. So recently me and my team has also done an Australian patent on LoRaWAN. Now we are going for another patent on smart cities and smart grids. Already have done 6 patents in my career, and 7 more patents I have already applied, which is actually surrounding Industry 4.0. So the last but not the least, we have the 4th layer as new services and ecosystems. And that's how we go for collaboration, addressment of the, you can say the controls, maintenance, everything. So you can say that I defend my word in front of you that why it is called an ecosystem, not even a technology. And this is the main shape of Industry 4.0. And this is what I'm going to tell you right now, that what if I tell you that the iPhone will be the first phone, or maybe the Samsung or Apple will be the only 2 companies that are actually thinking towards adding the phone structure without even involvement of a single human on assembly line. So we have digitalization, automation, connectivity, and analytics. And you can say that in the future, the phones will not be from plastic or other materials. Let's go for go green and sustainable production with the power of 3D printing. Yes, everybody, it will be the most adaptable technology in the world. And even you can say that even if we talk of space centers, in the space centers also, most of the components are not from the earth. They are actually printed there. And this is where the digital enterprise will come in terms of design, planning, engineering, production, and services. So you can say right from the start of one thing to the real world, with the digital technologies and adoption of modern infrastructure, we are actually making it as a value chain towards digitalization and integration. And if the digitalization and integration is there, naturally you have the globalization and sustainability in front of you. And this is the parallel approach, everybody, which I would like to share with some of the example in the next slide. You can say that we have the parallel approach, parallel production process, shorter time frames, existing infrastructure, but we need to improve it. We need to digitalize it with sensors, cloud computing, and IoT. Fast and learn with the power of AI. And above all, we need to make it low capital market. Today, many people ask me, sir, we want to bridge up a lab of IoT. We want to make a lab of cloud computing. We want to do some research on Industry 4.0. Is it an expensive affair? I always say, no, it is not an expensive affair. You just have to make a prototype, then show it to the industry, and maybe the industry will conceptualize it. And after that, you can take the funding. Let the funding comes from industry, let the funding comes from government, but you must defend yourself that what exactly you are working with your ready-made prototype. You can make a simple device for 300 rupees in your lab, in your home also. But the main thing is you must have an idea and you should know it's working. And then funding and grant will come to your way. So why we need Industry 4.0? The most important answer is reduction of cost, reduction of complexity, improvement in customer base, and the fighting of the cutthroat competition. So all these four parameters we actually require to make every industry a solid industry with a strong backbone for the mankind. So why Industry 4.0? You can see that as the computers will be working, as the machines will be working, I will be discussing in the part of cyber physical system. We will going towards faster production, 120% better and 70% reduction in time. Naturally, with this type of logistics, we will improve the profit, reduce the cost. Better quality. Machines are working. Who can touch the machines? Who can touch the robotic quality? Exactly, if you can do it. Increase productivity. And above all, this is the answer for all of you, that human beings require lunch break. They have Sunday, they have Saturday, they have the holidays, they are tired, they want sleep. But what about the machines? They don't require anything. They just keep on running and running and running. 24/7 operations without any problem. And these machines are connected to the internet and you can control the production anywhere and anytime. I will be showing you more demonstration. So with the power of improved decision-making and data science, we can make these sensors to work for us about the prediction, response, and adoption. So this is the Industry 4.0 value chain that you can see right now in terms of decoupling, next generation robotics development, intelligent power tools, and connectivity. So don't think that future Honda car or the flying car can be done by the same assembly line of Tata or Honda. It cannot be. Don't consider that the future MacBooks will be there in the current assembly line. They have to change it. FMCG, everything, they are improving the quality with these type of things only. So the design principles of Industry 4.0, you can see that we require interoperability, which means that we should have a parallel connectivity with cyber physical systems, backbone by Internet of Services and Internet of Things. But if you talk of the next generation, I'm talking of cyber physical systems, connectivity and interoperability with Internet of Everything. Virtualization. Today, smart factory, no workers. Decentralization, real-time capability, orientation of services, and above all, a modular, flexible, and scalable approach. And that's what we can say with the changing requirements, the factories change. So don't think that you brought a laptop today, you will just increase your RAM or just change the laptop. It is not a part of industry. Industry will change because Industry 4.0 will bring the modular, flexible approach for adaptability. So these are the 9 technologies, and you can all see that these technologies are actually the fusion transforming Industry 4.0 with big data, robotics, simulation, industrial IoT, cybersecurity, cloud computing, and above all, please keep a note on this area, everybody. That is called additive manufacturing. Lots of scope. You can say that if you are publishing a paper in 2021 with some case study using additive manufacturing, that paper will take less time to review and you can get some suitable and positive comments, even from transactions, I'm sure of that. And that's all the gap of Internet of Things that you can see right now. Again, the question stands in front of you, evolution or revolution? So it is evoluting, it is improving, it is revolutionizing everything. So Internet of Things is now outdated today. Don't consider IoT as the most talked subject. It is now replacing with Internet of Everything. Maybe in the future, it is also going to replace with artificial Internet of Things, intelligence of things. So IoT itself is transforming itself with modularity and flexible approach. And the technologies, I have already discussed it, so I will not discuss more. Internet of Things, Internet of Services, Internet of Data. And this is the entire ecosystem that you can see in detail now, that we have the suppliers with Logistics 4.0, robotics will work here. And this is the assembly line where robotics will be working. Okay. And this is the product that is being manufactured, which is actually being monitored by sensors. All the data will be on the cloud where it is properly secure. And we have the big data here performed with analytics with cyber physical systems. And after that, we can have mass customization. So you can say that every single component of the industry will be actually connected, not only connected, bridged. So it's a stage approach. Stage one, see the area, see the case study, see the problems. Then add some understanding to that with some value opportunity. What is the understanding by you? What is the AI techniques that you can use with the power of deep learning or blockchain? How you can solve the problem? I love to solve problems. Number three, prepare for that change. And number four, keep on adapting. So today, don't think that the project, once it is done, it is finished. No. Today, the project needs adaptability and modularity. So even if you implement a cloud server today, don't think that it is a cloud server that can run for years now. No, that is not the case now. We have to make the changes. We have to adopt new technologies. We have to make it more into a workable situation so that the end users can facilitate that. So that's why it is called a stage approach today. Now let's discuss cyber physical systems, most interesting part of this lecture. So what is cyber physical system? Now understand very carefully. Now I would like to give you some example with that. Now cyber physical system has three words. Now let us talk of the three words separately. What is a system? System means a set of activities that are being performed and they are interrelated, intercoupled with a boundary and they're operational in an environment. That is called a system. It could be a management system. It could be an income tax system. It could be anything. Set of activities are performed, having a boundary in an environment, interconnectivity and interleaving. That's the answer. Physical means that can be touched, which means a system that is performing some activities and can be touched, operational in a boundary and working in an environment. Consider your factories. That's a physical system. But now if I add the word called cyber, which means I am connecting that physical system to the cyber world and I give them the three add-on benefits: communications, control, and computation. That's why it is called computational intelligence systems, because we are actually having the operations that are being monitored, coordinated, and controlled. So it's the best definition that I can provide you right now in this lecture, what exactly is meant by cyber physical system. So imagine everybody, you have a cold storage, okay? And you have a thermometer there. And if you want to monitor the thermometer, you have to go inside and do that thing, which means it's a system that is operational and you are monitoring with a thermometer. It's a physical system. But what if I add a temperature sensor and I'm getting the reading regularly on my mobile app and it is giving me some analytics that, okay, at this time, the AC was working not good. At this time, it was okay. And we can do some predictions. That becomes actually known as a smart system for cold storage monitoring. And that system is actually known as cyber physical system. Even your robotics, even your smart home, even it is called a cyber physical system. So cyber physical systems are everywhere. Even let me tell you, if you talk of the very old example, you can say that there is an aircraft where the pilot is not control. You have the autopilot. Even autopilot is a cyber physical system where the computers are actually controlling the physical properties of aircraft and they're flying the plane. They can even land the plane. Energy and industrial automation, the smart meters, smart grids, cyber physical system. So IoT critical applications are actually known as cyber physical systems. Healthcare. So if you talk of those machines that can even take over the doctors, that I can perform the surgery in a better manner, it is actually a physical system that even can be controlled. That's called a cyber physical system. So applications in terms of critical things, they are abundance available in the real time. And this is what you can say a conceptualized map that is being designed for you to understand. Basically, the most important thing is a feedback and everything human in the loop. And after that, it requires cyber security and proper methodology, and applications are ample. I can say these are not only the applications, these are the critical applications that can transform and requires to be worked out, that how we can improve the right now the parts of our thinking and the well-being. So CPS as a system and evolution, you can say that we have control towards mechanical system, mechatronics, and above all, Industry 4.0. So let me tell you what is Industry 4.0. Industry 4.0 use adapting of these technologies and making the machines as cyber physical systems. So let me tell you, industry will be there, machines will be there, that physical system will be there, but to adapt the cyber technology, we have those technologies. And after that, if you adapt them, it becomes a cyber physical system. And if you make the cluster of cyber physical systems working for you 24/7, it becomes automated industry known as Industry 4.0. Very easy. So that's what we can say, cyber physical system, where I'm doing my research. Even we have published 2 or 3 papers also. It could be autonomous vehicle, it could be medical monitoring, robotic system, automatic pilot, anything. So this is the 5C architecture, which I would like to share with front of you, where we have the 5 lines. The last line that you can say that the first line that we can say is configuration level, cognition level, the cyber security, data to information, which means data science and analytics, and above all, smart connectivity. So you can say from every level that we don't want to stop at any place. We have connectivity everywhere. And these are the examples that you can see. So any machine of today can become the smart machine of tomorrow. The only thing is start and implementation. So you can see right now in this example, this is the workstation for today's factory, where a car is being assembled. Now this is today's factory. Wastage of time, wastage of energy, and even increase of the cost, reduction of the profit. And now see tomorrow's factory with cyber physical system, where parallel things, low capitalization, improved logistics, and the car can be ready in less than time. There was a time when Audi used to make one car in 5 hours or maybe 8 hours, but today Audi takes less than 25 to 30 minutes for making one car. So Industry 4.0, known as cyber physical system, when we have embedded systems added with smart sensors, and when we have the smart actuators, we are actually providing the connectivity, and this connectivity leads to an ecosystem known as a cyber physical production system, the CPPS. Very few papers are on this area, so please focus your research on this one. Okay, so this is what we can say, that the capabilities of cyber physical system will lead to smart industries known as smart X. So now let's deep dive into cyber physical system. I would like to give you some thoughts of mine in terms of examples. So smart manufacturing, where all the business and operational sectors are optimized to achieve sustainability. The most important thing is sustainability, performance, better support, and efficiency. That is what the smart manufacturing will all about. And you can say the question always people ask me that, sir, will robotics replace the human beings? I always say no, it will never. In the future, you will not even see the word called robotics. No, it will not be robotics. It will be cobotics, collaborative robotics, where human beings and robotics will collaborate each other. They will work to perform a particular task. So you can say that in the current scenario, we have low-skilled laborers, mid-skilled, and high-skilled. But if you talk of transformation, only the low-skilled, you can say the low-skilled operators will be replaced, yet the mid-skilled and the engineers will remain the same. And in fact, Industry 4.0 will generate more jobs. More jobs, I'm saying. And this is what you can say, the transformation by Industry 4.0 with today's industry. Mechanical sector, mechatronics is Industry 3.0, but with 4.0, we have the intelligent technical system. And that's what the transformation is all about. And this, you can see that a person is just putting an artificial intelligence camera on its tablet, and the graph is automatically coming, where the machines are talking to the camera that what is the production level and is there any problem, so they can report that, where machines talk to machines. That's called machine to machine interaction, human machine interaction. And this you can see with HoloLens 2. If the worker is a new worker and is on the training, the HoloLens 2 will tell you what exactly to operate and how we can make better production with sharp sustainability. And this is going to be the customized car, again, the future car that is known as fully automation, future intelligent transportation system with vehicular to X, that is called vehicular to end connectivity. We have the Industry 4.0 sharper production as a cyber physical system. And this is called robotic. And if your institute is well flexible and modular enough, so try to tap a company called KUKA. They are very less collaborative. They are only collaborating with top institutions of the world. And you can say this is a KUKA robot, where a person is working on an architecture, and the person is working and the robot is also working. So you can say humans and robots, human machine interaction to accomplish this work. And that's what we can say the future. So don't think robotics will replace you. Robotics will help you and collaborate with you. So the challenges, you can say, skill shortage. We need a strategic plan. Right now, the access points are limited. We have some cybersecurity concerns, but they are now gone. They are almost gone. And the most important thing is we need to think of cultural collaboration. That is what we have to say. But the start of investment will be high, but it will give you good returns. So these are the top 17 technologies that you can see on the screen right now with Industry 4.0 adoption with 2020 report by IoT Analytics. And right now I'm working on every technology, and me and my students are now working on some advanced communication standard like LoRaWAN. And we have recently started our research on Sigfox. And plus I'm a man of sensors, I'm a man of AI, I'm a man of drones, I'm a man of cobotics. So I do lots of research into different multi-dimension sectors. And this is the Industry 4.0 adoption by 2020. And you can see that in China, right now, the focus is only on, in Asia, the focus is only on China. So Toyota, Huawei, and Foxconn. So Foxconn is the #1 company, as we all know, all your iPhones, Samsung phones, Vivo, or the world's biggest producer of electronic components is Foxconn. So they are producing it. But right now, the #1 company that is into Industry 4.0 is Siemens. And this is the adoption by industry. #1 is automobiles, and #2 is computers and electronics. But still, you can say that with Industry 4.0 adoption, we say that pharmaceutical sector, because this is required in terms of clinical trials, new drugs discovery, and other things, we require that the healthcare sector can become the top 5 in the next coming 2 years. So I have already told you the answers. Siemens, a German company, GE from USA, and Boeing from USA. They are the leading adapters of 2020, but by 2020, 2021, maybe the game changer will be coming towards pharmaceutical company. And you can see this is the Airbus, the factory of future. Only one worker is working, and all the robotics are from KUKA. They are autonomously working and producing the aircraft. And this is the factory of the future. So we don't require any workers on production line. All the workers and high-skilled workers will be working on these type of machines and doing the research. And this is the Siemens factory, where you can say that the outer shell of the car, the shampoos, they are all working with the Siemens with Industry 4.0. And this is Honda industry. We all know Honda, the popular cars in India, and even Honda Activa also, which is the popular two-wheeler in India. This is all working by robotics. Just one worker is there, rest machines take over. And this is Amazon factory. Robotics are working. No person will be seen in this one, but you can say that Amazon can become the first company that is starting from the order, from the taking of the order, even to delivery of the order with drones and robotics will be done by Amazon. And the last but not the least, I will discuss the part C just for 5 minutes next. After that, the house will be opening for questions. The future of industry, that will be Industry X.0. So you can say that innovation, human-machine interface, and experience will be part of that. So the most important thing will be, it will not be one-dimensional, it will be two-dimensional, which means new services, and after that, acceleration with efficiency, with workforce and connectivity. And you can say that with wiser impact, shareholders companies, progressive technologies, everything will be taken care of. And this is what you can say that living products are at the core of transformation, with core of change, business models, ecosystems, and smart products of the future. And this is the market size of IIoT with Industry X.0. And you can say that only by 2020 and 2021, just with 1 year difference, you can say that it will increasing by $13 billion. So imagine who is not going to adopt it. Now, who is going to adopt it? It's a different thing. Who is not going to adopt? It's a question to think of you. Everybody will adopt it. And with IIoT, IoT will become a bigger ecosystem, which cannot be sufficed with IoT. It requires IoE. And in the nutshell, you can see the improvements. So the skill shortage, so the skill requirements for Industry 4.0 is the #2 I would like to share: complex problem solving and critical thinking. So AI and blockchain and IoT with the power of cybersecurity, these are the major skills that we require right now. So Industry 4.0 is there, X.0 is there. Are we ready for it? So this is a question for you to ask yourself, are you ready? So the conclusion is 80% innovations will take place. CPS systems will go on rise, higher precision and superior quality productions. and improvement in augmented and hybrid learning systems. That is what we see in the near future. So now the house is open for questions. You can just unmute yourself and ask the questions. And if you want to be in touch with me, here is my Instagram. You can follow me on Instagram. My website is there, WhatsApp number, and my email. So you are most welcome to collaborate, most welcome to send me your proposal for collaboration. I will be more than happy to collaborate with you. Thank you so much for inviting me. Now the house is open for the questions, please.
Thank you, sir. Thank you very much. This is really a very wonderful session, wonderful talk. So if any delegate having any query, any question, then you please ask from the sir.
Very well elaborated by Dr. Anand, and it's a pleasure to listen him that he share his insights. So thank you so much, Dr. Anand, for sharing your insights. And it was really it's interesting talk that we have listened today. Thank you so much.
Thank you.
Okay, so before inviting for our next invited talk, Professor Ranveer Singh Bhatt, I would like to introduce about Dr. Ranveer Singh Bhatt. So Dr. Bhatt is currently working as an assistant professor in the Department of Computer Science, Lovely Professional University, Punjab. His area of research include wireless communication, ad hoc network, cloud computing, and IoT. He has published numerous papers in the national and international journal in this area, and he has a vast experience of research in this area. So now I would like to invite for the invited talk, Dr. Bhatt. So now I am handing over the mic to Dr. Bhatt.
Thank you, brother. Actually, it's already 4 and I have engagement at right 5 o'clock with my higher authorities because we have a talk with international collaboration with the South Bank University, London. So I think we should first complete the session that we have initiated. So if some time left, then definitely I will start my talk. And otherwise, I will share all the content of my talk with you. So first, I request you, let's complete the session by 5. Right before 5, and if we get some time, then definitely I will deliver the talk.
Okay,
it's
sir,
all
okay.
because of we are running short of time.
Yeah, definitely, sir. Okay, thank
Yes,
you.
no problem.
So basically, we are having 7 paper in this session. So out of these 7 paper, 4 presenters are present here in this meeting. So now I would like to invite to the presenter for presenting the paper. First, I am announcing the sequence in which the presenter will present the paper. And I am requesting all the presenters, so please take maximum of 10 minutes to present their paper. So the sequence of presentation will be first paper presentation by the researcher Puneet Thapa, and then paper will be presented by Kamal Preet Kaur, then Pulkit Jain, and last by the Vijay Prashad. So I am inviting Mr. Puneet Thapa for presenting his paper. And the title of his paper is Comparative Analysis of Pre-Processing Techniques in the Automatic Skin Cancer Detection System. So handing over the mic to Mr. Thapa.
Hello, Mukesh sir.
Yeah.
Sir, sorry for interference, but there's Bhagesh Kumar, our PhD supervisor. He has also one paper, but he's busy with something. So me and Aditya Raj are going to present this hand gesture to text converter paper. So
okay,
if you can align it that way.
No problem, sir. You can present that.
Please make sure we are running short of time. So means whosoever is available, please proceed.
Okay. Thank you.
Because at 5 I have to leave.
Sure. My voice is audible?
Yes.
Yes, sir. Thank you, sir. So I share my slide with you first of all, and then we proceed. Yes, it's visible.
Yes, sir. It's
visible.
Thank you, sir. So kindly, first of all, correct my name in the list that is mentioned as a Puneet Thapa, but my good name is Puneet Thapar. So I will explain because the certification
Okay, sir.
problem is
Okay.
not occur during certificate. So kindly correct it first. So my topic is that is comparative analysis of pre-processing techniques in automatic skin cancer detection system. So in this paper, we will working on analytic approaches, or we can say the various analysis pre-processing techniques that are adopted for skin cancer detection system. We are working on a lesion detection first. So skin cancer on the basis of lesions, where scare marks, or we can say that a lesion on our body that is to be occur in the formation of a cancer stage also. So there are various stages of skin cancer like melanoma and non-melanoma. So this is the outline view of my PPT. That's first of all abstract view of my paper will be discussed here. Then intersection section, we will discuss the introduction used by what is our topic and what is to be done in this paper, and the various related work that is we have to compare, and the comparative analysis of your swarm based and another detection mechanism that is to be adopted in my paper that I will discuss in this. Abstract view of my paper, due to shortage of time they were given, so I will explain in the session. So we will explain that what is in this my paper. In this paper, we will discussing about a skin cancer diseases. Skin cancer disease, we say for some time there is scar mark. So we can say in the Hindi we say that a till in on our body, because that particular scar marks or a pigment cell that to be in a that stage that is to transform to a cancer stage. So cancer is it has a two type of skin cancer diseases, that is melanoma and no melanoma. Or melanoma stage is still difficult to detect. If it is detected, it's difficult to solve that situation. So if we detect them in early stage, or we can detect that in a non-melanoma stage, so that to be we effectively can be recovered from this. So our main task is to analyze the various skin disease sensors. So we will mention here in this paper, the detecting the skin cancer by automatic system presented. We will use an automatic system generation, and we are working on our comparing a various pre-processing strategies that are used to segmented out that particular segmented area or that pre-processing stage. So this is the main task here. So various image classification techniques, segmentation techniques, feature extraction techniques, concerning, or we compare them to get the better solution, or we will compare that which one is better. I will also share here. So now you see here, this is the past scenario of the American Cancer Organization. That this cancer stage is mostly American have this opportunity. They have a lot. Australian have also have a skin cancer disease. So the lots of the person of male and female are suffering from this skin cancer disease at Australia. This chart is presented by a Word of Cancer in the site. So I will calculate from this, or I will got this image from this site. In our task, this is different phases that is to be diagnosis during the image cancer detection, or we can say the skin cancer detection during melanoma or non-melanoma detection during a lesion detection. First of all, we will input the image. That image is not a simple image. That image is a dermoscopy image. That dermoscopic image means we have to be have a special tool available to detect that skin cancer image to detect. So we will pre-process that image first. So we have available of data set is available. ISIC is also providing a data set. Various other data sets are available, but I am mainly working on ISIC's 2017 and 18 data set that is available with us with various dermoscopy images. We will pre-process the images on the basis of very pre-processing algorithm we compare here, and after that we have to segment out the segmentation techniques are available, or we check that which one is a better one. We also compare here. We see that if some of the segmentation not provide you exact segmentation, or some provide us a better segmentation techniques. Or after that, we have discussed with the feature extraction technique they are adopted, what type of feature extraction technique they are using in their paper, and image classification method, what classification algorithm they are using. We compare these all. So image input in the form of dermoscopic images. You can see here the dermoscopic image in A and B section we have seen there. This is A and this is B picture. This is two types of skin cancer. Different types of skin cancer are there. Both are lesions. Dermoscopy we can both are lesion images. We will pre-process the image in a microscopic form. So we see that this is exact formation of this. This is exact formation of these blur. This is a blurry image. We can work into a pre-processing stage and then convert them into a actual formation, so that we can easily detect the stage of the cancer. So pre-processing is there and image segmentation is there. So pre-processing we have to be work on removal of hairs, shadows. If we have any bubble in the picture, in any skin line in the picture, we will remove these sections and we will provide the exact sharp image of our lesion. So this is the stage that is will be pre-processing. So various pre-processing algorithms are adopted here. After that, we will segment out the particular section of lesion from here. Means like this one, if this is image, we have to segment out that particular lesion from that particular stage. So to detect the accuracy. So there are lots of algorithms available. Some of them are mixing with background and foreground colors. So they are not accurate one. So we will study out which one is accurate one by comparing various algorithms on the basis of various survey. We will find out. So these are the features they are to be found out in their session. So there are some type of features like shape feature, like meaning like asymmetry, compactness, unharmonious diameter. These are the shape feature that has to be adopted during the evaluation. So on the basis of their shapes, we have to calculate these features. On the basis of texture, we calculate these features on corners, GLC, grayscale occurrence. These are the various features method, variance entropies, and on the basis of energy methodology, on the basis of contrast, on the basis of homographic, various features they have to be adopted for this. So on the basis of study analysis, we have found out that these main feature categories they are using for their feature extraction. After that, we have various classification algorithm available. We will see that on the basis of survey or comparative analysis, we see the deep neural network or a neural network methodologies are adopted very much in the classification methodology, or they are giving a better result as compared to other technology like neural networks, spot vector machines, fuzzy logic, general algorithm. These are the other processing listed techniques are available. But we will see that in comparative analysis, the DNN gives you a better result. Or pre-processing approaches in the related work, we will see that there are various three main pre-processing methodology they adopted. First is that is image enhancement, second is image restoration, and hair removal. These are the three main pre-processing to be adopted by skin cancer detection using lesion detection images. In image enhancement, we see that first of all we will scale the image. Scaling the image is required because if image is clicked by a dermoscopic scanner or dermoscopic any device that is clicked the dermoscopic images, so we have to scale them first to zoom out the size of the lesion, and then after that we have to transform this into a grayscale images so that we have to find out the background and foreground color easily. After that, contrast enhancement is there. We will enhance the contrast situation so that we will find out the exact segmentation section. If this is after this, then image is done with enhancement, a blurriness is removed here. So we will go for a restoration. Sometime image will be that it clicked is to be consist of some noise or some blurring mutations also. So this to be restored here at this stage, pre-processing techniques are adopted here to restore the image in the form of removal of noise or removal of blurring formation. After that, some of the body section have including hairs also. So we see that some of the skin lesion have covered with hairs. So with the help of morphology method and surveillance extraction method, various other methods are available to remove that hair section from the images to find out the exact formation of a foreground color of our image. So this is the main objective here. The main pre-processing approach, various approaches are using for pre-processing. We will compare there. You see this table will elaborate each and everything in detail. We have seen that comparative analysis of existing work for detection of skin cancer on the basis of what type of the pre-processing method they adopted, what type of segmentation they are using, what type of feature extraction method they are using, what type of classification method they are using, what performance they are providing to us. On the basis of these factors, these attributes, we will calculate the accuracy in sense of higher performance. So in 2016, Kenzie Moy or Murthy announced one paper with name. Then they are using a pre-processing technology like image scaling and RGB or gray image conversion and binarization. They are using three methodologies to generate a pre-processing stage. And next is that is they are using a segmentation methodology, that is blue detection, edge detection, and masking. This method they are adopted for segmentation purpose. And after the feature extraction method they are adopted, we have mentioned that these are the features they are adopted for this. And again they are using ANN here. ANN is the artificial neural network with accuracy 96.9, that is higher must to detect the image. In the medical field, we know that cancer is not a small disease, it's a very crucial disease, a critical disease. So we have to concern mainly on accuracy. How much accurate we have to predict, that is to be save the life of the patient. So this is the main concern. So there is 0.1 accuracy is also to be if someone has 1.1 accuracy higher than another one, so we have to consider that one, because this is very crucial to us. So in 2001, a color space transformation method they adopted. So they have only done with the segmentation accuracy of, they have done with only segmentation section. So actually 94% they don't mentioning of what segmentation method they adopted. So I will not mention here. Color space transformation, they are using color space transformation method. Edge based segmentation method they are using, but with lowest accuracy, no much heavy, very high. So and one of the method that is we will see that is better approach is k-mean. If k-mean is used as a segmentation approach, we all know that this will give us the better solution as compared to another. So we will see that the accuracy is very highest level at this stage, that is 97%. So we see that the another system also using k-mean as their evaluation. So we will find out the base element, that is k-mean as a segmentation method, and compare k-mean with other optimization algorithm, swarm based algorithm, to detect the higher accuracy. So you see this also hair removal sharpness contrast method they are using for pre-processing. So they are using a various other method of processing. So shortage of time, I will conclude with the, first of all we will show you the swarm based approach they are using. Came in a segmentation as a messaging by person. So to see there the combination technique like fuzzy c means, pso, k means, I will compare them with this chart. This chart will predict you each and everything of this. You see here, I will compare a k-mean with PSO, swarm based various algorithm, the PSO method, ABC, ठीक है, then CSA, CRO segmentation के ऊपर बेस आ गया, grasshopper के ऊपर. They are using these technologies. We will, when we will hybrid this k-mean segmentation approach with this swarm based scenario, the accuracy will be improved. We see the precision, recall, and FMAIR and accuracy is improved at each and every level. So we will see that this method is to be adopted at very much high rate. K-means with grasshopper will give you a better solution for this. So on the basis of this, we will study that on the comparative analysis we presented with the help of the graph, precision, recall, and FMAIR of each and every stage will be at k-mean with grasshopper is very high. So we will compare this. So on the basis conclude this PPT, we see that KNN is a better approach, or artificial neural network will be also adopted here for classification. So this, I think this paper is helpful for the further researcher to detect the automated detection system, to detect the lesion detection for their approaches, or they're using any, if anyone has work on a thermoscopic images for image segmentation or for digital image processing, they can follow my paper also. So this will give us the detail about this is also helpful to reduce the time related to the comparative analysis. So I will compare each and everything here. So due to shortage of time, so I will cover out my all PPT. So if any query from anyone end, you may ask me anytime. Thank you. Welcome for questions.
Puneet ji,
Yes.
yeah. So which data set actually you have used for this?
ISICs.
Sorry?
ISIC.
Okay. And which technique you have used for pre-processing?
Sir, pre-processing, we are using a technique that is this one. I mentioned also here. These methods are related work. So we will survey on these paper, image enhancement method, image scaling, these all techniques I will adopt it, or compare them with various papers to get better results.
All right. So if
My
anybody
question
have
to
any
you,
questions.
sir, that what is the core analysis that you have observed after making the experimentation?
Core analysis, I will observe that key on the basis experimentation, we will see this figure or examine that key this main key we have to be clear out with the highest accuracy we need, because this is a medical and we need a higher accuracy. 97% already
What is
occurred.
the
We
bit-
can't say
but-
that the higher
but
accuracy is
what
more
could be the
needed.
real-time implementation for this thing?
Yes, sir. Please.
What could
Pardon?
be the real-time implementation for this thing?
Real-time implementation. Real-time implementation is used for, we can say, in the medical line, a user can we can implement in a various labs also to detect the dermoscopic images. With the help of dermoscopic images, would not need to be go for any another test. On the basis of dermoscopic image, we can detect that the cancer stage of a person, if they have any cancer stage or not. So if you have, our system will, our research will give you them 100%, up to nearby 100% implementation. So it will help for the out for better detection. So this is our task main. So I will work on k-mean with grasshopper. So k-mean with grasshopper is the better approach. That is I study out. a better give you a segmentation methodology, a better solution for us.
Okay, thank you, sir.
Thank you, Puneet.
Thanks a lot.
Okay, thank you, sir. For the next paper presentation, I am inviting Madam Kamalpreet Kaur, and the name of his paper is Effective and Efficient Clustering Approaches for Data Mining. Okay, for the next paper presentation, I am inviting Mr. Pulkit Jain for his paper presentation.
Yes, sir. Is my voice audible?
Yes, sir, yes.
Okay. So I have my members with me. So I'll just upload the presentation. I'll share with the screen. Just wait.
Okay, sir.
Is it visible, sir?
Yes, sir, it is visible.
Okay. So the topic of my paper is design and implementation of Li-Fi based DTMF controlled bipedal walking bot. And myself, Pulkit Jain, research scholar here in EC department at Chandigarh University. My co-authors are Dr. Paras Chavla, professor, EC department, and Harsh Goel and Saurabh Nayak, students in mechatronics department, Chandigarh University. So I now hand over to Harsh. Harsh, now you can start.
A very good afternoon to all the dignitaries here. So, our topic is about a walking bot that is being placed in the industry and is controlled via DTMF controller using Li-Fi technology. So, the first question that we come around today is Li-Fi. What is Li-Fi? What is light fidelity? uh, Majorly today we are having so many communication technologies such as radio technologies, IR sensors, and different modes of communication. So why do we need Li-Fi as the new age technology? As we are talking about Industry 4.0, I believe that Li-Fi will be the future mode of communication because it is much more secure today and in future as well. uh, all of us have been using Wi-Fi through our mobile phones or laptops, but we all know that it is quite insecure because it could easily be hacked from outside the room or anywhere else. Whereas the benefit with Wi-Fi technology is that the range within which the light is being received, only information can be retrieved within that range. So in this paper, we have basically developed a prototype of a bot which is being placed within the industry, and I'm able to control it from miles of distance anywhere using Li-Fi technology. During this COVID situation, we have been trying to discuss about mobile manufacturing, that is manufacturing in industry 4.0 using my mobile phone or any device. I can control the manufacturing within the industry from any mile of distance. So can we move ahead with the slide? So I will give a brief introduction about certain things that is we have used in this paper. The first question is, why a bipedal walking bot? In an industry, we have been using different kinds of bot that are either wheeled or legged bots. So why do we need a bipedal walking bot? The answer to this is the walking motion of a human body is more flexible. We have more degrees of freedom while operating. So if in an industry we need to perform an operation of climbing a ladder, a wheeled bot cannot perform it, but a legged robot can easily perform it. It has much more flexibility in moving within the vicinity of the industry and also performing tasks similar to that of the human body. The benefit with Li-Fi is that whenever the LED blinks, it blinks at such a fast rate that it cannot be visible with the naked eyes of our human. But when the information can be encoded in that blinking of the LED and can be retrieved on the other end using photodiodes or even solar panels. We have also introduced a term called DTMF, dial tone multiple frequency. So I will give a brief example about this DTMF, that whenever we dial from our mobile phones to customer care, we are being instructed to press a specific button, example 1 or 2, to proceed further for something. So what is this 1 or 2? If we will see the keypad uh, keypad out layout of our mobile phones, there's a two-way frequency that is in horizontal as well as in vertical direction. So the combination of both these frequencies will decide which number has been pressed. So we are using this kind of a DTMF decoder to decode the frequency that we are receiving at the user end. Uh, Components. So we have I have explained about DTMF decoder in this. So we have used SC9270 decoder in this. We are using a GSM module. So GSM module will be the one that will receive the frequency and will further communicate with the DTMF module to process the data along with the controller. We are using the Arduino Uno controller for this purpose. And further. This is just a layout of the bipedal walking bot that we have developed for our prototype. So this is a 6-legged robot. We were able to easily perform the task on a 4 degree of freedom robot. Servo motors are being equipped in the C clamps and the L clamps of this bipedal walking bot that has an aluminium fabricated design. And so we are within the controller, we have coded about this at what direction and what angle the motors should rotate to make the bot walk. So here I will try to explain the complete working of our prototype. So let's consider that within the industry, I have placed my robot, which is a bipedal walking robot. Now I am sitting 1,000 miles away from my industry. I am having my mobile phone in my hand, and mobile communication networks work over very large range. So through my mobile phone, I will dial a specific number. Now within the industry, where I'm having my GSM module 900A, that we will program this in a way that it will automatically receive the call when I am calling to these numbers, and through an aux cable we will transmit these frequencies to the LED light source that is installed in the entire industry in my manufacturing area. So on my bot, I will be placing a receiver, which is a solar panel in this case. This receiver will retrieve this the signals or the information coming from the LED sources and will transmit this data to the DTMF decoder. Now this DTMF decoder will convert that frequency into a binary or a decimal number, which will be which will work accordingly to the controller, the program that is being fed into the controller to work specifically. When supposedly number 2 is being received, it will start walking ahead. Number 8 is being received, it will start walking back. 4 for the left and 6 for the right. So these are the basic motions that we are trying to create through this. So it is more secure because mobile networks can work over very large range. Secondly, it is very difficult to interfere this light communication method within the industry. And in the era of COVID, where we are talking about installing mobile manufacturing techniques to make to mobile manufacturing techniques, so this is quite cheaper as well. Here we have divided the entire thing into two parts. What is the transmitter part and what is the receiver part?
Sir. Excuse me, sir. Sir,
Yes,
can
sir.
you please come towards your working screenshots only? Thank you.
Back. Yes.
Just show the working only. Yeah.
Yes.
Do you have any other screenshot for this?
We might have one or two screenshots. Not at the moment, but
Okay, come to the conclusion, please.
yes. So the conclusion is that DTMF is a secure medium along with the Li-Fi technology. We are also working in the researching something about Li-Fi underwater communication through Li-Fi, and we are able to do something regarding that as well. Li-Fi technology is more secure in future, and there have been possibilities to transmit image, transmit video, and even transmit audio signals using this Li-Fi technology. Thank you very much. If any questions that.
So Praneeth, you are done with your presentation?
Yes, sir, we are done with our presentation. So if any queries anyone has, we will be happy to answer the questions.
Sir, I have a suggestion that next time when you do the presentation, also add the circuit diagram so that we can know the working, and even add some animated photos so that we can demonstrate that you can demonstrate that how exactly it is working.
Yes.
And
Okay, sir.
I have a doubt that what is the critical application for this robot, and why you have used this is the sensors and the embedded board that is quite outdated. Why not you are using the advanced boards like Pine 64, Raspberry Pi 4, or Lati Panda, which is actually being designed for this type of robot? Why you have not used the latest ones?
Okay, sir. Thank you for your question. Firstly, our main aim in this paper is to basically make the use of Li-Fi technology. So we wanted to make the circuit as cost effective as possible. That's why we went for Arduino programming. Main aim was to, you can say, to get a hands-on experience with Li-Fi technology, because this is in you can say trend. Nowadays, Li-Fi technology is used in underwater communication as well, where the divers, they can communicate with one another. Like one can have the audio signal, video and image transmission via Li-Fi. So this is just an introductory, you can say, step towards using the Li-Fi technology, where we have combined this Li-Fi part with by designing a bipedal walking bot. So main aim was, as we can see in this slide as well. So
you can focus more on some critical application that where you can solve some real problem, Because
Okay.
today, if you talk of robotics and IoT, we are actually
Yes.
concerned because the paper can only get accepted in international front when we have some critical application to defend of. So
Okay.
my suggestion is that Arduino is okay, but now you can practice with some more embedded system boards, and you can use some better sensors from Texas Instruments, and
Okay.
use some standard Li-Fi technology for that. Because nowadays some sensors are also there, which you can abridge, and you can go for some real-time operations like that.
Okay, sure, sir. Your feedback is very important for us.
Yeah.
We'll definitely try to work on this. Thank you, sir.
Yeah, sure, sure.
Yes.
Thank you.
Pulkit, on the basis of this Li-Fi technology, what are the various available robots currently? Have you did a little bit of R&D on that?
Robots, sir. Actually, I have.
Pulkit, are you there? Uh,
Sir, we can start with next
yes,
presentation.
please. Yes, please. Dr. Nanda, are you getting the voice?
Yes, sir. Yes, sir. We can start with the next presenter, please.
I mean, as I can see that Dr. Meher is means he's narrating something, but I'm not getting the voice.
So can I start myself, Vijay?
Yes, sir.
I am the last presenter. I don't know whether I should start or not. I'm not too sure.
Yeah, please, sir. You can.
Sir, sir, actually, we were to go. We were not able to have Meherchan. I just got a text from my mentor. He told to start. So can I go ahead?
Yeah,
Please,
sure.
please.
Okay. Can you give me this screen sharing access? Okay. So good evening, panel. So myself Sameer Kathal, and I am a final year student at Triple IT Allahabad, and I have with me here Aditya Raj, my classmate, and Mr. Bagesh was not able to join, fortunately. So I am presenting our paper on hand gesture to text converter for deaf and dumb. Now, basically, these deaf and dumb people, how do they communicate? So they have three major components. One is finger spelling. They use their finger. They use hand and gestures, finger gestures, to spell character by character. Other one is word level sign vocabulary, in which gesture, like hand gesture and something, is mapped to a specific word, like ASL, American Sign Language, and all these use that. And other third one is non-manual features like facial expression, tongue, mouth, body, all these other things. So we are focusing mainly on finger spelling here. So we are focusing. So in this paper, we are basically producing a model, CNN model, which can recognize finger spelling gestures in real time and can use it to form word character by character. So, and we have this advantage of each person can use his custom data set for corresponding gesture to like character mapping. So this eliminates the problem of lack of like the problem of sign language dependency. So if someone knows ASL, that is American Sign Language, and someone knows Indian Sign Language, so they find it trouble to communicate with each other. So this eliminates that. Now what the basic problem definition, the crux of the problem is in real time we are capturing 30 frames per second. So for each frame we have an image, and then what we have to do is we have to map out the corresponding letter, the character which is mapped to that corresponding gesture. And this is done by the model which we are going to propose. So I'll call upon Aditya Raj to present further from here.
Yeah, hello. So our proposed methodology goes with these 5 steps: data collection, pre-processing, training, testing, and finally the output generation. Forward. So data collection, we have used an in-house data set where we have actually extracted out the images from videos of the hand gesture. We slowly moved our hands and captured the videos, and based on that, we extracted out 1,000 images for each symbol for training and 100 for testing. And for data pre-processing, we have applied a Gaussian blur filter of size 7x7 on all the images. And also we have rescaled the image to 100x89. This is the standard size which is used for AlexNet CNN architecture, which we'll be using in this. Forward. So yeah, training phase, we had 28,000 images. There were 28 classes and 1,000 training images for all those classes, and we fed into an AlexNet architecture of CNN. And this is this is the standard AlexNet configuration. Next. So yeah, there were about 6 lakh parameters in this, and we use the categorical cross entropy loss for this. Mini batch gradient descent was followed, and 0.001 learning rate, and these are the epoch details and the batch size details. Next. Yeah, so for the output generations, basically when the application starts, first we have to generate the background. So for generating the background, we have tried various processes like color-based segmentation and hue saturation segmentation. But then we came up to a method which is called weighted average technique to generate the background. In that, we take 30-second images taken of the background, and based on that, a background is formed. And once the background is formed, whenever we put any object in front of that, the mask is clearly means accuracy is very high. There is no redundancy in that. Like we see the hand images here in this picture, we can see that it is pretty clear, and this we have used for further training. Next. Yeah, this was our system architecture. We took the images from the webcam and converted it into grayscale, then did smoothing using Gaussian blur, and then the background subtraction, and then training and output processing. So these were our gestures. The base paper which we followed, they had 26 alphabets and we added few alphabets for correction. Like we made a editor, a word editor. In that we could even delete some characters if it is wrong. We can do space bar, enter, and change paragraphs. So we can actually write anything we want using that. And also we tried various algorithms like SVM or K-means. But after the comparison, we found out that CNN was better, and most better was the AlexNet architecture, which we went forward with. Next.
Okay, so the basic advantages of this approach, as I already told you, that it eliminates the sign language dependency. And other thing is that a user can use custom templates or custom words for gesture if she wants to do that. So this is like a screenshot of her demo. So what it shows is here is gesture expected. So each character takes about 6 seconds. We fed it into a dictionary, and then for 6 seconds we have to keep it like this. It shows a predicted character, the confidence, the word, the current word, and the sentence. Our method achieved an accuracy of 98.28%. for 28 character classes with this assumption that the background has no lines and edges. It may, the lighting conditions can be somewhat different, but this lines and edges part, this needs to be there. So this is our training accuracy graph. So we can see that after around 500 steps, it more or less becomes constant. And this is a validation accuracy. If we average it out, then the difference between this training accuracy and validation becomes lesser on near about 5K steps. The future scope for this is firstly if you want to increase the speed and the accuracy of our model, so what we can do is we can have two CNN models. So what we found out, various characters from this first model were very similar in kind, and they were very similar in kind. Yes. So what we propose is that we can have another CNN model for these 6-7 similar characters. We can train that second CNN model on these 5-6 character images, and then whenever these 5-6 images are output from the first model, we can pass it into the second CNN models, which will further increase the accuracy, and at the cost of reducing the and the cost of increasing accuracy, we will have this prediction time reduced for each character, which is currently near about 6 seconds. And second, what we can propose is we can have autocorrect and autocomplete features. So whenever a word is being fed, there is a Python library like Hunspell autocomplete. So what it does is, if we input the initial characters of a word, it displays out the matching character, matching words, and
Yeah. Okay. Okay.
yeah. So this is
Can you
yeah.
please on your cameras, please, all of you?
Okay, sure.
Yeah.
Uh,
First of all, I would like to inform you that the research that you are doing, it is actually published in lots of research papers. And if you see website like Medium, Digest, and Towards Data Science, you can find that there are lots of tutorials also. Even I was seeing this type of tutorial. But my question would be for you so that you can defend the research. My first question to you is that have you compared your proposed model with some existing models, and you have compared them in terms of accuracy, error reduction, or other things? How you have validated the accuracy of your model?
So we have initially we used SVM model, SVM,
No,
and
that is okay. I have seen your paper. My question is that you are claiming that you have done an accuracy of 98%. I fully agree with you. Okay.
Yeah.
Have you compared your model with some existing model? Like suppose I propose this protocol, okay, like this pen is a protocol, and I compare this with another protocol. Then I can compare that my pen is better than this pen. Okay. So my question to you is how you validate your accuracy of this model as compared to other. Have you compared with other models?
as far
Actually, we looked into different papers, and in that we got different accuracies. We ran one of the we ran one of the models, and in that it shows near about 92%, 93% accuracy. But
Okay.
like different hyperparameter tuning was there, and so based on that, we tried to increase the accuracy from what we have executed in previous
But sir,
models.
I want that the research that you have presented, that is okay. But I was looking for something new, something add-on, because the parameters, the CNN layer, and everything that you are showing to me, that is actually known, because I have also done this work on that, but we have done it on NVIDIA Jetson Nano. We are using the Jetson Nano for this type of AI activities. But the main thing is that how you are converting that sign language into the text form. What is the accuracy and how much time do you take to convert? Like suppose if I do the sign language of 5 words, how much time does your model takes to convert that?
Well, actually, what we had that we had like a box when we executed it. We had an area region of interest.
Okay.
In that, it showed that now we can put the gesture, and when the gesture is detected, we have now put a time limit of 6 seconds.
Okay.
Because for every like frame, it is capturing what is the predicted character. Based on that, it is taking the maximum of them. So
I want that you should work more so that I can work on some real time. Like suppose if I don't know the sign language, okay, and a person is putting up the sign, so I can put my cap, or you can even design a mobile app that if I put that person on that mobile app and how I can convert the text, like we do like a Google Translate. So I look forward like a translator system for a real time. You can note it down and you can use it for the further application, because this is actually a problem. But you can say that I need some more enhancements from your side, that how we can take it to the real time and make it a critical application solution. That is what we see. But if you can make it for real time, you can even apply for like a 3 impact factor journal like that.
Okay, sure, sir. We'll look into it.
But sir, I would like to show you that when you go for a research paper, like this is my suggestion, that when you are claiming some accuracy, try to compare, like, okay, sir, that we have compared the model number 1, this is this person, model number 2, this person, this is the accuracy, these are the parameters, and this is our graph as compared to that. So that comes like an analysis of experimentation, like comparative analysis. That is what I wanted to see in the paper, because I already know the concept, but that is what I was waiting for, but it was not there. Anyways, it's a good gesture from you, but it has lots of scope. It has lots of work to be done that you can do in the near future. Thank you.
Okay, sure, sir. Thank you for your feedback.
Mayor sir, your voice is not clear.
Yeah, I think my voice is audible too now.
Yeah. Now audible.
Thank you very much. Now the next speaker is Samir and Aditya Ras. Is there Samir or Aditya?
Sir, we just presented right now.
Okay.
Yeah, they presented, sir.
Okay, thank you. So right now next is paper ID ICCTIM 243. Kamalpreet Kaur is present?
No, sir. I don't see her in the participants.
Vijay Prasad have done. I think if there is any person who is present here to present his paper.
Sir, I have not done the presentation yet. Myself, Vijay Prasad.
You can do, Mr. Vijay Prasad. You can do.
Vijay Prasad. Okay. Your paper ID is 263?
Yes, sir. 263.
Recognition of characters in Devanagari script text in natural science using ANN, right?
Yes, correct, sir.
Yeah, you can start your presentation.
Okay, sir.
Sir, do we have any other presentation after this, or any other presenter?
Yeah, I think this is the last presentation.
Okay. Can you share your screen, sir?
So I'm just sharing.
Yeah.
I hope my screen is visible.
Yeah.
Yes.
Conclusion is visible.
Good afternoon, everyone. I myself, Vijay Prasad. We are 3 authors in this paper: Pranab Das, Dr. Pranab Das, Dr. Y. Jayanta Singh, and I am presenting this paper. This paper is recognition of characters in Devanagari script text in natural scene using ANN. Basically, in this paper, we have tried to frame, we have tried to create a data set, and that we have tested with simple ANN technique. So I'll just go through it. So this is the content of the presentation: abstract, introduction, Devanagari script overview, data collection, data set, pre-processing, experiment result.
Excuse me, Mr. Vijay. Can you please come to your work only? You can skip the introduction. You come to your work only.
Sure, sir.
Yeah,
Sir,
you can start with the data set. After that, you present your work, that exactly what you've done, because this is the main theme. Yeah.
Sure, sir.
Devanagari, we know. Just come to your work only. Yeah.
So in this particular paper, main work is the data collection only.
Yeah.
Because in natural scene, with respect to Devanagari script, we hardly could get the data set. So we have tried to collect. So right now we have been building our data set.
You have made your own data set.
Yes, sir.
That's great. That is That is good. Appreciate.
So this is what I want to elaborate on this. So right now we have 410 images as of on this slide, but we have already crossed 500. We are still in the stage of processing. So number of average word in each image is around 7.3 with 410, and total number of words is 2989, and number of characters, like as you see, we are also trying to extract each of the characters so that we get higher accuracy later when we start processing. So in fact, for collecting the data and extracting the image, we have made a small tool also, the glimpse of which is visible on the screen, wherein we are able to extract each character, get the location and save it with the particular location. And later on, we have also, I will say, supervised learning. Which character is this? We have built that. And I'll directly now, sir, basically this is the main work. Data collection is the main work, and we have done pre-processing like binarization, normalization, background noise removal, skeletonization. This is the experiment which we have done wherein pre-processing, and we have done feature extraction wherein we have extracted 55 features, and basically we have used a very base ANN tool wherein we are extracting the feature vector, number of wherein the horizontal line and vertical lines, diagonal lines, left normalized length of all diagonals. So this feature vector consists of around 55 vectors, and then we have used this algorithm to help us in feature extraction, compute the input image centroid, divide the input images into n equal zones, and compute the distance between image centroid to each pixel present in the zone. Repeat step 3 for entire pixel presenting the zone. Compute average distance between 3 points. Repeat this procedure subsequently for entire zone. Finally, and such features will be obtained from classification and recognition. Then we did the training with neural network feed forward backpropagation model for the training. The number of nodes in each input, hidden and output layer with will determine the network structure. The network consists of 55 features vector of each input node corresponding one feature in each 6th zone, 80 neurons in the hidden layer. Then transfer function, we have taken log sigmoid as transfer function. As a result, to get the result between 0 to 1, MSME mean square error is the performance function parameter taken. Learning rate is taken to be 0.5, and the performance goal what we have achieved is 0.001. Result each feature vector consists of and the first 55 elements, which where the first 54 features are obtained from the 6th zone, each zone having 9 elements. The last 55th feature element is the Euler number for particular image. It is defined as this difference of number of objects and number of holes in the images. The extracted features are given as input to the system. The structure of neural network includes the input layer to hidden layer, and each layer each with 83 neurons and an input layer with neurons. The gradient descent backpropagation methods and log sigmoid transfer function are used for neural network training. We got best result with train DX algorithm performance plot, which is shown on the screen. That performance goal is met in 599 iteration using training DX algorithm. These are feature plot graph for 2 characters we have shown. Then this is the accuracy that we are getting. We have not yet completed for all, but some characters we have completed, and we are getting accuracy on average of 78%, something like that.
That is even better.
So that is what I have to present, sir. Main part, sir, again I am repeating, main part is our data collection. We are, and
but the main question is, that is okay, But the main question is what type of technique, like are you using like what type of like linear regression or random forest or SVM? What type of machine learning technique?
SVM, sir. We are using SVM right now, but soon we are also working on CNN, sir.
But I recommend that you can also test into random forest. I don't know whether I will be correct or not, but I can say that random forest can give you some encouraging result that you can
Okay,
check.
sir. I'm making a note of it. We will definitely try.
Yeah, you can check. You can check because actually in machine learning, when you're doing this type of novelty research, then we have to just go for like trial and error method first of all. But maybe I can say you can check it. And secondly, as you can see that I would like to ask you one question, that what was the major challenge in this research from your side? What was even today you are facing some challenge? What was the major challenge?
Sir, major challenge is collecting the data sets. Once we have a complete data set, right now also, if I say we have reached around 500 images, which is somewhere around 22,000 characters also, still the number of frequency of each character is still we are lacking. We are thinking that once we reach around
you can do one thing. You can do
yes,
one
sir.
thing. Let me tell you, it is a very short path, but it is an accurate path. Now you do one thing, you just meet some painters who do the paintings like billboards, etc. Tell them that, okay, you just draw whatever it is, and you take those photos and you can put the training of the set. Because naturally, if you're taking the data from these type of billboards, it is automatically done by some painter. You can go to some painter, you can extract that information and you can update your data set.
Sure, sir. Thank you so much, sir.
Naturally, suppose I am the painter, I'm doing some painting. Naturally, my painting will be published on the real time. Okay, so you can contact some painter and you can take his handwritings and you can train your data model. That is the shortest path that I would like to recommend you. It's a very you can say shortest path, but it's an accurate path. That is what I believe.
Sure, sir. We'll try that. Thank you, sir.
But I would like to suggest you one more thing, that kindly complete the paper. And if you can attain the accuracy of 80% plus, then you must try to publish your paper into Springer multimedia tools and applications.
Sir, with CNN, we have already crossed around 85%
If you have crossed 85, then it is a high time that you can submit your paper into MTAP journal, because I'm over there. I'm the strong reviewer, so maybe I can support your paper.
MTech journal, sir. Sir,
MTech,
can you please?
MTech, multimedia tools and applications.
Sure, sir. Thank you, sir, so much.
I'm one of the top reviewers of this journal.
Sure, sir. Thank you so much, sir.
Thanks for this nice presentation. If there is more any paper presenter, please raise your hand. I think all the presenter has presented their paper. Thank you, dear Professor Anand Nair, and I would like please conclude the session.
Okay.
Yeah.
So thank you so much, Dr. Meher, for first of all inviting me for this prestigious conference. And I have observed that all the papers are very good. People are doing lots of research into critical applications, and they have a strong potential. Like I've seen the last research from Mr. Vijay Prasad. I'm quite impressed with this type of research when some new type of activities or new type of problem or critical application takes place, and a person is doing a wonderful job in terms of accuracy. So conferences like this should be organized, and even you can see that conferences like this have COVID-19 has not stopped the conference, has not stopped our connectivity. Either I can say that COVID-19 has brought more connectivity to us, because at one time when we were not able to reach the conference, we are able to now attend every conference that we have to attend. So all the best to your institute for organizing this conference, and keep on organizing the conference and focus more on collaboration with the SCI journals, as well as some Scopus index journals for some add-on extension to the research papers that are being published.
Thank you, dear Professor, for your valuable time in this session. This session was organized under the theme of advanced in computational intelligence and its applications, and various papers has been presented in this session. And time is now about to over. Tomorrow we will join the same 8:10 a.m. First session will be start. So thank you very much to give this time, give your precious time in this session. Thank you all of the members who present their paper in this